Hey everyone, welcome back. Today we're going to check out some tips to boost your game's performance in Godot 4.3. Whether you're working on a 2D or 3D project, these methods can make drastic improvements to your game's frame rate. A lot of these are going to be physics-focused performance improvements, but there'll be some generic tricks mixed in throughout. This video is a collection of performance tricks I've discovered over the past 4 years working with Godot, and is in no way a complete list. We'll try to focus on Godot-specific tips, so I won't be going over programming best practices or Big O notation, for example. I've divided this video into little chapters for each tip, so feel free to skip around wherever you need. Also, a quick note, premature optimization is often a big time waster, so use the more complicated tricks on an as-needed basis. After all, we're using Godot to make games, not get lost in endless optimization rabbit holes. All that said, let's dive into number 1. If you're working in 3D, one of the best performance boosts you can get is by switching to Jolt, a physics engine that's dramatically faster than the default Godot physics system. You can install it by going to the asset lib, searching for Jolt, clicking Godot Jolt, and then download. After downloading, the editor will restart. But we still have to go into our project settings, search for physics, and then you can see under 3D, you can switch out the physics engine used by our project. If we switch that to Jolt, we'll have to restart one more time, but then after that, Jolt should be ready to go for your project. Jolt integrates great with the default node system, so no need to learn brand new physics nodes or anything. Now, for all the 2D devs out there, unfortunately, you can't plug in Jolt to improve your 2D physics performance. Not yet, at least. The good news is you have options. I'd say Rapier is definitely worth a shot if you're looking for performance gains. Switching to Rapier can give your project the boost it needs, especially if you're dealing with a lot of colliders. You can install by going to the asset lib, searching for Rapier. Now, there's a few options here. You have cross-platform determinism and whatnot for 2D and 3D, but I'm just going to go with this one, the fast version. Next, we download, and then install. We'll have to restart real quick. Then we go to project settings, searching physics, and under 2D, you'll see you can switch out the physics engine used by your project. Switch that over to Rapier. You'll need to restart again, but after that, Rapier 2D should be ready to go for your project. Like Jolt, Rapier integrates great with the default node system, so no need to learn brand new physics nodes or anything. Next up, lowering the physics tick rate. This essentially reduces how often the physics engine calculates interactions. You can change the physics tick rate by going to Project Settings, Physics, Common, Physics ticks per second. Now you can set this value to whatever you want, but to increase performance you're going to want to lower it. But you can also raise it at the cost of CPU resources if you need extra fluid physics calculations. Lowering it can improve performance drastically, but it comes with a big warning. If your tick rate is too low, you risk missing fast collisions that happen between physics frames. This is definitely something you'll want to experiment with, depending on your game's needs. One thing you might notice after lowering the physics tick rate is that all your physics objects, especially the faster moving ones, lose some of the smoothness of their movement. If you have a really low tick rate, it'll make your game play like a PowerPoint presentation. But thankfully, there's a new feature introduced in Godot 4.3, Physics Interpolation. This smooths out the rendering between physics frames, giving you more fluid visuals. Just be sure to set the physics jitter fix to 0. And if you run into any unwanted teleporting, use Reset Physics Interpolation on the offending bodies to fix it. Another big one, reducing the number of colliders and areas in your scenes. Every collider and area you add means more work for the physics engine. If you get to a point where you need to make physics optimizations in your project, try removing redundant areas or physics bodies in your scenes. For example, let's say you have an enemy scene you need to render a bunch of all at once. This enemy has an area acting as a hurt box, receiving damage from collisions, and also a character body to collide with solids. To optimize here, you could remove the hurt box area and move the damage dealing logic to the external areas that hurt the enemy. This basically halves the amount of physics objects that need to be simulated at once for the enemies. So a lot of you will probably be familiar with the move and slide function and the character body node, and because it's incredibly handy and used all the time in games. But move and slide can also be very heavy on performance if you're using it for more than a few hundred enemies. Depending on your game, you might want to switch to more efficient methods for handling movement and collision detection. If hard collisions aren't a requirement for your game, you could consider using soft collisions. This is basically switching your physics bodies out with some lighter weight area nodes that repel each other via code when they get too close. These soft collisions can actually be highly optimized to let you drastically increase the number of nodes in your scene. There's actually a project I found that does just this. It's called Mini-Me's. It was created with the sole purpose of loading as many enemies on screen as possible. You can see it's not difficult to have several thousand enemies colliding at once with stable FPS using the strategies in this project. Now, there's a lot of other optimizations used in Mini-Me's, like interacting with the physics server directly, using raycast and shapecast and frame skipping, for example. But I'll leave the repo for Mini-Me's in the description if you're interested in diving into the specifics of these optimizations and how they could be implemented. I would highly recommend. Though keep in mind, when you're moving off of move and slide to a different solution, it can lead to undesired changes in how your physics objects interact with each other. It's all about balancing features and performance. For those looking to squeeze out every bit of performance, consider using C++, C#, or Rust for your CPU-intensive code. These languages allow you to bypass some of the overhead of GDScript, leading to faster code. I find GDScript runs fast enough for most games, but the option to program in other languages is there if you're needing an extra boost, or even if you just simply prefer another language. I'll link some of the documentation on getting started with these languages in the description. You can also reduce the number of solver iterations in your project settings. You can find solver iterations under Project Settings, Physics, 2D, or 3D, but for this one we'll do 2D. This setting controls how many times the engine attempts to resolve physics interactions per physics frame. Fewer iterations mean better performance, but you might sacrifice some accuracy in collisions, so be sure to test this out if you change this value. Again, it's all about finding the right balance for your game. And if your game is really heavy on physics, consider running physics on a separate thread. This is another project setting like before. You can get there by going to Project Settings, Physics, 2D or 3D, and it's up here at the top. Checking this option will offload physics calculations from the main game loop and can vastly improve your game's performance. Multithreading is another option to improve performance of some of your game processes. It allows you to run sections of your code in parallel. It can be pretty tricky to implement though, so it's not always recommended. It is good though when you have a heavy world generation, for example, and a single thread can't quite keep up with the train generation. Another powerful performance saver is writing compute shaders. This is a tool that allows you to move your logic to run massively in parallel on the GPU. And you guessed it, like multithreading, it is tricky to implement. But it is impressive what can be achieved when using the power of the GPU, like this Boyd simulation project by Nice Effort 1. They were able to run a Boyd simulation with 100,000 Boyds using a mix of compute shaders and particle shaders. It's incredible. I have a link to this video if you'd like to see the whole thing. I would definitely recommend. These are some more advanced topics, and I'd like to dive in and learn some more about them when I get a chance. I'll probably make some other videos covering multithreading and compute shaders in detail if y'all are interested in seeing what implementing those strategies look like. And for those who are using GDScript, using Godot's built-in helper functions and classes can have a significant improvement on performance. While the engine itself is relatively lightweight, the helper functions and classes cover a lot of ground. Calling them runs a fast C++ implementation, instead of the slower one if you were to write it yourself in GDScript. And plus, they prevent you from recreating the wheel, saving you development time. There are a bunch of these utilities classes. You have Geometry 2D, A-Star 2D, Physics Server, Vector Functions, Tweeners, Math Functions, Surface Tool, and Mesh Data Tool, for example. Another little trick, the way you load in resources and scenes also impacts your game's performance. It's generally best practice to preload or export the scenes or resources you want to instantiate via script wherever possible. Dynamic loading of assets is slower and can affect performance negatively if done repeatedly. Dynamic loading can be hard to avoid sometimes, so don't feel like you can't dynamic load anywhere because preload is faster. So there you have it. Those are some of the best tricks to boost your game's performance in Godot. Every game is different, so try out these tips and see what works best for your project. And if you like this video, don't forget to hit that subscribe button and drop a like if you enjoyed. There are probably plenty more tricks to improve performance that I didn't cover in this video, so feel free to leave a comment with any of your own Godot performance tips. Well, you've made it to the end of the video. That's all I have for now. But thanks so much for watching. I'll see you around.